In this video, we're going to be looking at inverse functions. So an inverse function is the function that we need to do in order to get from the output back to the input. For example, if we have a function which is x to 3, in order to get back to the original number, we have to subtract 3. So the inverse function is x minus 3. So we know that we can write a function using the fx notation. In order to show that something is an inverse function, we use this f minus 1 of x function. Also, if we inverse the original function, we get back to the thing that we started with. So if we put x into a function and then do the inverse, we get back to the thing that we actually started off with. And of course, we can only do an inverse function if the original function is a one-to-one function. If we had a many-to-one function, when we tried to do the inverse, we wouldn't know which of the possible inputs got us the certain output. So when we start drawing graphs of inverse functions, something that is quite nice is that if there's a point called AB, then on the inverse graph, that point becomes BA. That's because essentially the input becomes the output, and the output becomes the input. That's kind of shown here on the diagram. If you do A into a function to get B, the inverse will then get you back to A. So if these ABs become BAs all the way throughout the graph, then what we're actually going to get are two graphs with a line of symmetry. And that line of symmetry is always going to be this y equals x. So you could reflect one graph through the y equals x line to get its inverse, which is given there in the box. To show you how this looks in an example, if this red line is the original function, this is the y equals x squared plus 3 graph. If we reflect it in the y equals x line, we get its inverse function, which is shown here as a green line. Now, the one thing we need to note here is that these two things aren't actually proper one-to-one functions, but the reflection idea still is valid. Another thing that we can see from this graph is that the function of x graph, which I'm just going to call the red one for now, where it equals the inverse function, always occurs on the y equals x line. Here's one point, and here's another point. Now you may see questions at some point that ask you to solve this particular equation. It might say find a value of x that satisfies this equation. Now if I try and make x squared plus 3 equal to positive or negative the square root of x minus 3, that could be quite tricky to actually work out. So what it might actually be easy to do for these types of questions is set fx equal just to x. Rather than making it the red line equaling the green line, we could pick either the green or the red line to equal the blue line because they all cross at the same points. So let's have a look at a couple of examples then. This first one is talking about the function x squared minus 2. And it says the domain here is only between 1 and 3. It says we need to draw both graphs on the same diagram and then compare what we find out about the domain and the range. So let's quickly go ahead and label our axes. And then we're going to draw our functions. So the first function I'll draw will be the function of x. I'll do it in red. So if we plug in 1, we square it and we take away 2, we get minus 1. If we plug in 2, we end up with 2 again. And if we plug in 3, we get 7. And if I try my best to sketch what this might look like, it's going to look something a bit like that. And we can see from here that the range is -1 all the way up to 7. So we can put that in this table over here, -1 to 7. I'm now going to draw the y equals x line so that I can then reflect in that line. That doesn't look too bad at all. So now if I try and reflect the red line through the green line, that will get me the graph of the inverse function. So I'm going to do this by doing the AB and BA idea. So this 1 minus 1 is now going to become -1, 1. 2, 2 is still going to be there. And 3, 7 now becomes 7, 3. And that doesn't look too bad at all. That almost looks like it's a decent-ish reflection. So now let's have a look at the domain and range for this inverse. In fact, let me just label these lines. Okay, so the domain for the blue line, well, it starts at -1 and goes all the way across to 7. So that's -1, -1 to 7. And the range, well, it starts at -1, sorry, it starts at +1 and goes all the way up to 3. So what do we notice? Well, we notice that the domain for the first function is the same as the range for the second, or its inverse, and the range for the function is the same as the domain for its inverse. This will always occur for any inverse functions if it's 1 to 1. So now let's look at some actual questions from previous exams. The first one says a function called h is defined as 3 over 2x minus 1. And what we need to do is find an expression for the inverse and then state its domain and its range. If we need to find an expression for the inverse, what we need to do is rearrange the subject of the function so that rather than it being h or h brackets x, we get it as just x. And then at the end, we kind of just do a little bit of switching back around and writing it in its proper form. So we're going to take this expression here, and we're going to try and write that as x equals. So I'm going to write h equals 3 over 2x minus 1. Hopefully you are happy with the idea of just switching these two things around. If I times by 2x minus 1 and divide by h, that gets me to a line that says 2x minus 1 equals 3 over h. I'm now going to add 1 to both sides. Now this thing on the right hand side, I can simplify a little bit nicer. If I was to write 1 as h over h, this becomes a fraction that says 3 plus h over h, which is a little bit nicer, because my next step is I need to half both lines. So if I write x equals 3 plus h over 2h, and that gets me my answer. So this here is the inverse function, and all we do now to show that it's, or write it in its proper form, is we change this x back to h minus 1 of x. So the inverse function is, and then what we do on the other side is anywhere there's a h, we change them back to x's. So 3 plus x over 2x. Now we need to find the domain and range of this inverse, and we're going to use the knowledge that we've just learned on the previous slide that says the domain of the actual function becomes the range of its inverse, and the range of a function becomes the domain of the inverse. So if I work out for h of x what its domain and range are, we can then flip these around and write it for the inverse. Well, the domain was already given. We already know that x must be bigger than a half. So now we just need to try and work out what the range is. So this x number here must always be bigger than a half. If it was a very, very, very slight increase from a half, 2 x's would get us a number like 1.00000001. Then when we take away the 1, we've got a very, very small positive number. 3 divided by that is going to be almost infinity. Okay, it's going to be a big number. We could make it as big as we want depending on the difference between the number we choose and a half. If we go to the other extreme and make x a really, really big number, well, if we double the big number and then take away 1, this denominator could be massive. And 3 divided by a really big number is going to get us a very, very small number. So by putting in those types of numbers there, we've established it's always going to be positive, it's always going to be bigger than 0, and it can be as big as we like. So we can say that the range for this function is bigger than 0. So then when we want to work out the inverse properties, so the domain is now going to be the range. So we're going to say x is always bigger than 0. And for the range, this was the previous domain. So h minus 1x is always going to be bigger than a half. Same idea here for question 2. We need to find an expression for the inverse. This is the other type of rearranging the subject where we have multiple x's on one side, and it's just a reminder about the factorizing step that we have to do. So if I was to write this as f equals 2x, x plus 1, we can multiply both sides by x plus 1. Let's multiply the brackets out. And then let's move all the x's onto one side. Then we factorize, so we're going to bring out an x. And then we can divide by that 2 minus f. So now we've got x by itself. And it's just a case of doing this finishing line where the x now becomes f minus 1 of x. And the f's become x's. So the inverse function here is x over 2 minus x. Another idea, another type of question here is just going to test us on our knowledge of logarithms and exponentials. So we've got f equals e to the 2x minus 3. So we're going to add 3 first of all. Take natural logs. And then divide it by 2. And let's write that in a nicer form. So we're going to say the inverse function is a half ln of x plus 3. Now the second part here says we need to solve the equation f minus 1 of x equals 0. Now there's probably 2 different ways we can do this. The first method is just by setting this equal to 0. So if we double both sides, then if we do e to both sides, we get e to the 0, which is 1. So x is going to be 1 minus 3, which is minus 2. Now the other way of thinking about this is if we look at that line there, this says the inverse of some number gets us 0. So that means at the beginning we plugged 0 into the actual equation to get x, and now we need to go backwards, do the inverse of x to get us back to 0. So what we could actually do is just plug 0 into the original equation. If we do f of 0, that gets us e of 2 dots of 0 minus 3. Well, e of 0 is 1. 1 minus 3 is minus 2. Both answers are the same, and it wouldn't matter which way of doing that question to get the right answer. I suppose it all would depend on how awkward both this function here is and what the original one was. So here's the final example we're going to do. We have a function which is x squared minus 8x plus 12, where x is either equal to 4 or greater than 4. We need to find the range, find an inverse expression, and then sketch them both on the same diagram. Now for these questions, it's always useful to complete the square first. So let's have a look at what happens if we do that. We're going to get x minus 4 squared. We need to take away 16 more, but we already had 12, so there's an extra minus 4 there. Now the reason this is going to help us is because if we wanted to find the range of the function, if it was an x squared graph, we should know that the range for the x squared graph is always going to be x is bigger than 0, because the minimum point is at 0, 0, so the lowest y value is 0. This here is just a translation of the x squared graph. We can see that we need to move 4 right and then down 4. So we could almost mentally sketch that type of graph in our heads. And we can see that the range here is always going to be minus 4 or bigger. We just need to check that it actually works for our domain. In this case it does. When x equals 4, this becomes 0, it cancels out, and we're left with this minus 4. So for part A, all we need to say is that the range of f, so f of x, is bigger than or equal to minus 4. To complete the square version also helps us with the inverse. We've got f minus 1 of x equal, just going to write it out again. Okay, so if we say f equals x minus 4 squared minus 4, we can add 4 to both sides. We can now square root both sides. So let's talk about positive or negative. And then we need to add 4 to both sides. So I'm just going to write it as 4 plus or minus the square root of f plus 4 equals x. Now before I make this look a little bit nicer, I need to think about this plus or minus. So this inverse function is going to take us from what we would have called the output and taking us back to what the input numbers were. Now we know from the question the inputted numbers, the domain, must always be bigger than or equal to 4. So if we look at this, if it was a plus in the middle, that would be fine, because 4 add any number is always going to be 4 or bigger. But for the minus, if we start off with 4 and we take away this thing here, that's going to get us a number that's always going to be smaller than 4. This means that we don't really want the negative part of this equation. So when we write out our actual inverse, we don't want to include the negatives. So the inverse expression is just 4 plus the square root of x plus 4. Finally, we need to sketch the graphs of f of x and its inverse on the same diagram. Now because it was quite a complicated diagram to try and sketch, I do have these ones already drawn, so let's have a look at them. There we go. So the red one is f of x, and then to sketch the other one, we should draw the y equals x line, that's the green line, and then the blue one is the inverse.